1 3. Hey guys, what's up? So in this video we will talk about the big O notation, the importance of big O notation. For getting into why the big O notation is important, what is big O notation or any of those things, let us look into two functions which I have written on the wall behind. So this is the first function, this is the second. Okay, let us focus on the first function. It looks quite jumbled like this. Yeah. So we have created a function add up with with a parameter n, and these are the code inside it. So what does this code do? It will just add numbers up to n. Like for example, if you write 3, so it will add 0 plus 1 plus 2 plus 3. 0 plus 1, 1, 1 plus 2, 3, 3 plus 3. So when you will write it, I'll show you this in the laptop as well. So it will give output 6. So how have we implemented it? So this is the most intuitive way, that we will create a counter named total and we'll set it to 0, and we have put it inside of our function itself. There's no problem adding it inside the function. And after that we have added a for loop which starts from I equals to 1. You can even set I equals to 0 also, no worries. All right, one more iteration anyways, and it will go up to n less than I is less than equal to n. Okay, if there is 3, then I is less than equal. So i's value will go from 0, 1, 2 till 3. If n is equal to n, is in that case I will be equal to these. Okay, so what happens what happens inside the for loop is that we need to, here a line is written, total is total plus equal to I. It basically means total is equals to total plus I. That means every time it will iterate. For example, for the first time, when total is equals to 0, then total plus, in the first iteration it will happen like second iteration it will be total is equals to total plus 1. Now it will, now I will change, now it will change to 1 is equals to, the new total will be equal to 1 plus 2. Now if new total will be equal to 3 plus 0, 0 mein ho gaya 2 mein aa gaya. Now it will be, I guess, right, like that only till n. So the final total will be, okay, like that. And after this for loop finishes its work, then we'll just simply return the total, the accumulator which has accumulated the values gradually by adding I to itself. First I was 0, as I explained, then I became 1, I became 2, I 3, I became 4. It just added itself to the new I, right? This is how it. So this is a very intuitive way of doing it. Now there is some other way of doing the same thing, which is using this mathematical formula, n into n plus 1 by 2, like that arithmetic arithmetic sum and all, AI, GI, AP, JP, arithmetic progression and geometric progression. Those mathematical chapters we have seen this formula being. So we will see which is actually faster. What do I mean by faster is that when you execute that function, like from the time of execution till the time we get the output, what is the time taken? So what the time will be taken in this, as you see there are like a lot of lines written in this, very less line written in. So an intuitive idea would be like this would take less time. Whatever it is, we'll see, and we'll see how we will move towards the acceptance of an idea of big O in this thing. So let's move into the laptop.
Hey guys, we are on the laptop, and here you can see I have this and this window. Okay, let me just divide this window actually, and snippet.js, just replace it. Yeah, so we have two functions as I showed you. I've written them down. We reduce my size as well. So anyways, so this is a function and this is another function. This is math wala implementation, this is intuition wala implementation. Like this is the kind of a code you can come up when you think about how to solve this problem. And we have down here we have applied some timer. Like this timer will check the execution time for executing this code with a n value of 1 billion, and this will also do the same. Basically I've copy pasted both the code for timer here, on the left and the right side. So first we will execute this code and let's see what is the timing. So we'll say control R. Okay, alert R something. No, nothing is working. I don't know how to make this work. Run without debug. We'll use Node.js and we'll try to run it. So it took this much time, 0.68 seconds. This is in seconds, okay, by the way, to execute this. And we'll do the same this side. Control D. What is that? Control D? Control R? It's not. Okay, anyways, we'll manually go into it. And we'll just click on run and run. Yes. Where did it go? Okay, so it took way less time. You see, way less time in this one. So we can say that for the same input, both of them give different time execution. So how? Let me just explain the timer code for this also. So we have defined t1 as our variable which checks for performance dot now. The timer starts like T1, like this records the time when this program was started, and after that we execute our function. We invoke our function with 1 billion as n value, and after that we just set L2. After this execution has happened, it will immediately jump into L2, and again we have done performance.now. Okay, and by subtracting both of them, we get and dividing that by 1000 because it gives the output in milliseconds. So it will give the output in seconds. So we have used some ternary operators here. I mean, you understand the point, right? So it just times basically, like at the very beginning and till the end, time taken to execute the code. So you can see both of them has different output. And the funny thing is, when you execute this code again, what do I mean by when you just go here and try to run it again? See the we'll see. So this was okay. Let's record our output. This is the first output. That's this is the second output. You see the outputs keeps changing. You see the outputs keeps changing. The outputs keeps changing. But now when we'll try to run and debug this part, the output here also keeps changing. So on the same system, on my same very system, the time of execution varies. So timers are useful, like these timers to check, which function is faster and which function will take more time to execute, which is better. But this is not a reliable or universal method of checking that our functions are fast or slow. So in order to solve this, because it gets very bloody, but we can have a good idea like which function is faster using timers. But there is a better way to actually judge them, and that is the introduction of big O notations. We'll do that in the coming videos. Done.